Yeah, there is one fun fact about Łukasz. Who can guess what was the programming language that Łukasz used 2 years ago? Yeah, so Łukasz was a .NET developer 2 years ago, and I'm really happy that I helped him to convert to Ruby. So, yeah, so Łukasz will talk about a real-world project that is happening, where RailsEventStore was introduced, or more in general, event-driven architecture was introduced. So, really practical situation. I hope some of you will. Yeah, do something like this as well in your projects sooner or later. So yeah, let's welcome Łukasz and good luck.
Thanks, Andrzej. Yes, I have to admit, 2 years ago I was addicted to .NET. Andrzej took me out of this. I'm really grateful. Yeah, so it's a big pleasure to be able to speak as the first here in this conference. I'm first time here. Guess why? I was a .NET developer. But yeah, I will tell you about how we work with RailsEventStore in Cashflow Management System. You already know my name, so I can skip this slide. I work in R&C company on a daily basis. We save Rails legacy projects, so if you have any issues, you know where to hit us. And in this talk, I'll tell you about 6 stories about how we work with RailsEventStore in Trezi, the Cashflow Management application. And it's good to start with what is a Cashflow Management application. So this is an application which helps your small business to take care of your cash flow. You can check all your bank account balances in one place. We also do some accounting for you, so you don't have to wait for your accountant to do it once or twice a year, which is usually the case. And RailsEventStore is an open source implementation of EventStore for Ruby and Rails, established in 2014. And it acts as a library for publishing, consuming, storing, and retrieving events. And in this talk, I'll be mostly talking about event sourcing in combination with event-driven architecture. But also there will be a tactical domain-driven design pattern and also tests. Tests will be really important actor of this presentation. So is anyone of you familiar with this picture? Please raise your hand. Do you ever see it? Yes, some of you will not talk about that. So with this background set, let's go to the first story, which is called the one with the open banking provider. As I told you, we are Cashflow Management application, so we need your bank account data, right? But we don't write the integrators on our own. We use third-party providers, so-called open banking services. And those services send us the data. So for example, we can show you the balance of your all accounts, but also your transactions and so on. Based on this data, this information, we can calculate useful reports for the small businesses that use Trezi. And the banking providers integrate with us through so-called webhooks. So they basically hit our API and they send us some data in the payload. And there are at least 2 approaches that one can follow to process a webhook. First one will be synchronous approach. So when we receive a webhook from the banking provider into our REST API, we can pass the payload from that webhook like a hot potato until it lands in the loving embrace of the database. And it works, it's good, but the question is, what if something fails on the way to the database? For example, in the application layer. And there's a lot of things that could go wrong here. For example, well, we just may violate some index. The schema of the database might change. We may have processing logic error, and so on. So what if there was another solution? And for example, instead we could store the payload as a technical event. So there is the first relation to event sourcing, right? Instead of just saving it into the regular database, we store it in the event store. And once we store it, we also can publish it to the queue and process it asynchronously. So this is how it would look like. So when the banking provider sends us a webhook, it of course goes to our REST API, and then we store and publish technical event. Then there is a queue that, well, takes this, and then there is an event handler that would be interested in processing this and getting the payload into the database. together with some calculations and making useful reports. And there are certain benefits in that approach. First of all is that we have external system audit log, right? So we have all the payload information stored as our technical events, and we can basically access them whenever we need or we want to. This is very useful for debugging and troubleshooting. We also have improved performance. So the responses to the third-party systems are super fast because we don't process any data, right? There is no call to the database. We just, well, there is to the event store, but we simply store it and then do nothing else. We also publish the event, but that just takes the milliseconds. And later on, we can process it asynchronously based on the processing unit's availability. And what's really cool about that is that we can scale our web server, which is receiving the webhooks, right, independently from the web jobs. So we'll probably have more web jobs processing the webhooks and not the many web server instances. And the last but not least, we don't have to rely on the third-party retry mechanism. Because once we have the payload stored, if something goes wrong, I can always access it, right? It's already mine, I could say. So if there is a bug, I need to reply my code. I can do it whenever I want. I can try as many times as I want. And I don't rely on the third-party provider and when they send me a retry payload, and because they may never do that, or they may do that in a couple of hours, and I may need it as fast as possible. So this is helpful, and keep that in mind, as in the next stories I'll be referring to that. And let's go back to the open banking provider once again. So I said that we decided to move processing of webhooks into async processes, right? So one question pops up in mind: what could possibly go wrong here, right? Because there is no such a thing as a free lunch. There are a few awesome benefits that we have, but also there is a drawback. The problem is that the webhooks that are now represented by events may come out of order, right? It may change. It's not guaranteed. So, and the order matters. And consider following example. When there's a webhook received with a balance of bank account for 100, and then we publish it as a technical event, we also store this information, and we fail processing this webhook. And then another one comes for the same bank account with other balance. We publish it as a technical event, and we start processing it. We process it successfully, and then we start once again processing the first one. We just overwrite the data. We don't want to overwrite the data. So we need to solve this problem. And I think it's also a good moment to stop for a second, or maybe for a minute, as the slide says. And I want to tell you about the project that we work with, because some of you may think that, well, it's a greenfield, but no, it's not. It's a code written in a startup way, and I think that a picture explains more than 1,000 of words. So sometimes I feel like this. When I want to change one really small thing, I have to watch out to not lose, to not just, break some other house electricity. So what does it mean in the code reality? For the most of the concepts in the system, there is one relational data model that represents this entire concept. We call it logical coupling, right? And I will not fool you. It's a common thing in Trezi, and that's fine because it did the job. It earned the money, it made us go forward, but now when we know it, extending that model at this point of time would be wrong. Because we already knew that it is too big, and now when we need to add another column and another information to it, it wouldn't be a good solution. So instead of, we decided to go on with a new model. And after a few iterations, we came up with something like this. So basically, the white boxes is the information that the class needs. So it's quite not so many, right? Because it's only external provider, timestamp, the status, and ID. Of course, we always need an ID, right? And it has 3 operations. So I will start from your right side. So the open method, which basically opens the bank account. It's used when it's created as a new one. Close method, which closes the bank account, meaning that we shouldn't process any more webhooks in here, and perform an operation. And there you can see yellow boxes. The yellow boxes are the rules. So once again, we used event storming notation here. And the first rule is saying that I can perform an operation when the bank account is not closed. The other one says, and this is the problem that we are solving initially, is that I cannot process this webhook if the timestamp is older than the currently applied, right? So this is going to protect us. And this is how it looks like in the Ruby code. So some of you who attended the workshop may be already familiar with that, but what you can see here is that this is a very simple Ruby class. It contains it includes the aggregate root gem, but you don't necessarily need that. But it allows us to use the on and apply methods, which are used to deal with the events. On method is kind of applying the event state to the class itself. Apply is storing the event, and later on it's also used to publish. So as you can see, this class is event sourced, and it has one simple task to do. It only checks whether the operation can be performed or not, and that's it. But I have to admit something. We had to be really pragmatic here, and but because we didn't have time to rewrite half of the system and do it by the book, as with the first picture that I told you that we will not talk about, where you normally have to write to the aggregate or in your write model basically in one transaction, and your read model should be updated like in eventual consistent manner, right? We didn't do that. We didn't have time for that. So what we did instead, we had to be pragmatic, and you write to the bank account. This is the top, to the new model, which is on the top. You can see the stream and infra aggregate root, where we instantiate this class and then perform the operation. Should look common. And then there's this block of code where we just add the read model information. And in my opinion, this is good because it's hard to always be perfect in a real project, not in a demo one, and to follow all the patterns from the books that we see, at least from the scratch. Eventually, we may get there, but those things evolve, and sometimes it's just not possible to do it from the scratch. And there are also few assumptions here. The assumption is that the stream will always tell us the truth, because there may be multiple reasons to change the bank account state. For example, if we use a soft delete with act as paranoid gem, which we unfortunately do, then it may be deleted for multiple reasons, right? But when we see in the stream the information that bank account is closed, then we know it's closed and we shouldn't do anything with this bank account. So there's another story with the bank account, which I call the one with the closed bank account and missing events. So you can see already that perhaps we introduced some problem in the previous story when we implemented the aggregate that keeps track of this performing operation. And so this is what actually happened. So when we received the webhook, and then the webhook was published as a technical event, you already know this pattern, then we started processing it, but it failed. And the error said it failed to save the record. I was really surprised, because there was no problems with this code. So I take a look at the stream. It looks healthy. Like the bank account is not closed. All right. So I took a look at the code, I did some static analysis based on the bug, and I noticed that it passed this line, everything was fine here, weird, and then it failed on the save. And did I mention it only happens for specific bank accounts? Yeah, that's the true story, best thing to debug ever and to reproduce with test. So what I do? I harness the most advanced debugging techniques and I reply the event, because I can, right? It's in my event store. And it turned out that the read model was soft-deleted for some reason. But there was no closed bank account event, right? And we should have it because we just said the stream will tell the truth. So I was thinking, like, where's this event? And remember, it was the bank account aggregate was introduced to keep track of that. So closing should always go through the bank account. And in the healthy stream, it looks like this. You can see the event on the top. I hope you can see it. It says that bank account is closed, and then nothing is after it, because that's the intention. So I took a quick look around the code. It looked fine. Test green. And you remember that we didn't separate the reads and writes, at least not separately, right? So it was always going together in one bank account transaction. And that's actually what happened. Someone was introducing a new feature to kind of close the bank account, meaning that we should ignore all the webhooks for the coming data. Why they would do that? Because sometimes the banking provider sends you too much information. Sometimes you have your bank account, but also your credit card. You don't want your credit card, but hey, you cannot configure that on their end, so we have to ignore it on our own. And this feature was introduced, but someone just forgot to add the second class into the equation. So they didn't write to the aggregate. And write must go through the aggregate, right? We said that it's the source of truth for this part of the logic. And one of you could say that it's wrong, that that we kind of have two sources of truth. And I would say in the most of the context, depends on which context, but you would be right. However, we made a conscious decision that our goal is to keep the source of truth in the stream. Therefore, there is surprise, but human errors happen, right? So now it was time to fix it. And in order to fix it, well, first part was really simple, right? Write a test, make it red, add this bank account class, write to it, make it green, but you can publish it to deploy it to production, okay? But now you have to backfill the data, right? It's also a very important step in this pattern. And I call it a cost at the point in time, because like previously I said, we couldn't afford rewriting half of the system. So we used only the part we needed from the pattern to have this visibility. And the startup world and the application in the startup world, there's a kind of fast pace of moving, right? So there was just no time, and basically the business wouldn't allow us to do such a modification and introduce full CQRS with 2 databases and so on. And that's fine, because the system doesn't have to follow one pattern entirely. It can just use the best of it in current context. Whoops. Okay. I didn't touch anything, guys. Okay. So bear with me. This is not the only aggregate we'll talk about. But first, I want to tell you about the story with pending transactions. Yet another issue that I had to solve, and where events helped me. So having events in the system that is asynchronous, but also depends on the external provider data, is very helpful. But first, let me explain you what are the pending transactions. So one of our banking providers notified us about new feature that, hey, we can send you transactions that are not fully processed by the bank, so your customers can see them really early on. But when we send you a new batch, you are supposed to remove those transactions. And it's your responsibility. It's like, okay, let's use it. And after a couple of weeks, when this was on the production, we got a bug reported by a customer. And they said that they don't see new transactions, the bank account balance is not right, it looks like the old bank account balance. And there was a time where I was hearing this 2 or 3 times a week. And I was like, yeah, so another guy that doesn't understand that we are not a bank, but we only act as a third party, right? Because we are not even third party. But I checked our events, I fetched the data, and I noticed that there was a really huge delay. Because there was 2 weeks of delay, 700 transactions missing. And I thought like, wow, this is really cool. Not. So I went to the open banking provider page. It has this nice console, well, some of them. And then I checked, and they actually send us those events, send us those webhooks, blah, blah, which we then persisted as an events. So I did a little bit of debugging. I also took a look at our monitoring system, and I noticed that once again, it failed to save the record. So my first thought, not again. But then I was like, yeah, okay, so someone must have broken it. So I git blame, right? Another event sourcing thing. But there was no changes. So I'm like, okay, they must have changed the payload. Payload look healthy. So once again, most advanced the debugging techniques, and I replied the event. And then it was quite easy because I found it. So as I said, provider required us to remove those pending transactions, right? And that's what we did. We followed the documentation, we followed the instruction. However, those were soft-deleted. And thanks to the Act as Paranoid game, which I really hate, but it's not so easy to remove from the project, we run into a small issue. So how do we fix that? Well, first, what I like to do, and I encourage all of you to do when you fix a bug, write a test to confirm that you really understand the bug. Then, of course, you can fix it. Then deploy it. And now, for some of you, it will end here, but I can replay the event. Make it right. I don't have to wait for another webhook, right? Normally, I would have to wait until the bank provider decides to send it to us. And I can make the customer happy. Which leads us to another story with transactions, once again. And this one I called the one with too large transaction model and classification. So, as I told you, we have transactions in the system. And we need to classify those transactions to calculate accounting, to calculate cash flow, and other usable reports for the customer. So one way of categorizing your transaction is to do it manually. So as you can see here, I can select whichever transaction category I like for my traffic car transaction. Traffic car is the car that you can rent in Poland. So once I do that, I checked and I selected the travel expenses, and you can hopefully see that the first one is green, and the other one is just a border of green. And those means that those transactions are automatically classified for the user, right? Because, well, we don't want them to do it on their own. That's not the purpose of buying software. So, as usual in monoliths, this was built in the beginning, and there was one model that kept growing, and it became too large at a certain point in time. And there was a lot of business logic spread around, like everywhere. And the worst part of it was that it was spread in event handlers. So it was asynchronous. And the model, it was very flexible because, well, you know, just a simple database model, right? It doesn't protect you from doing any rules. So it's just a blank sheet of paper when you can basically write anything, it will accept it. So it's a DDD at its finest, database-driven development, of course. And yeah, I told you already, trade-offs. This was a startup. They had to do it quickly, but at a certain point in time, we need to adapt the system to be more scalable and maintainable. So at this point, we had quite a lot of bugs regarding the transaction classification. Some of them were wrong. Some of them felt like they should be override by another method. And it came clear for the business that this is important part. First of all, customers keep complaining about this. Second of all, it's like a base for all the reports that we have. So it has to be right? So when we understood it and they understood it, we could start a project. So we decided to give it a shot and try to rewrite this part in order to make it more stable, but also more predictable. So luckily, also, a few weeks before that happened, and I think that was also one of the reasons, there was new classification method introduced, like a automatic one. So I wrote some exploration tests for that POC that became a permanent solution. Never happens, right? And the one thing is that without tests, this project would be too risky, and I think I wouldn't do that. I would start with the tests anyway. Those were integration tests, and they're really helpful because with the event-driven architecture, well, it's sometimes unpredictable how the system will behave if you put the events in different order. And yeah, write test. Why there was no test for the POC? Why did I have to write that? I can tell you off the record. But anyway, the project. The project was about respecting classification rules. So I told you we can classify transaction, right? And then once we classify one, then the algorithm will learn based on that knowledge, and it will automatically classify others of them, and so on. And let's focus on 3 classification methods. So one is manual classification. This is the one that I showed you on the previous slide. The rule classification is it's based on the wording. So you can say that if transaction contains certain wording, then use this category. And automatic ones, there's a couple of them, but they can learn either from your account or other accounts and other stuff. And as I told you, they were spread around in the code in multiple event handlers. And our project was to encapsulate those business rules, right? We saw that there is a lot of if statements. Some of them looked very familiar and similar. And also, sometimes it felt like the if statement is missing in this and that place. And because of that, we have many bugs. So we decided to introduce an aggregate to fully encapsulate it. This is how it looks like. There's a couple of methods. I think there is more raise calls than other code, but this is how we decide to protect the rules by throwing in an exception. And as you can see, once again, it's very simple Ruby object, right? It doesn't have any external dependencies. It doesn't depend on the active record. It should be easy to unit test, right? Because you don't interact with the database. And once it was developed with 100 of mutant coverage, we felt like it's good to start adding it into the current process. And there is a test for that class, so I really hope this looks easy for you, because it's just a pleasure to write such a test with the events-based assertions are definitely really simple. But before we started using this class in production, we decided to extend the existing test. And once again, we use the streams for that and the events in that streams. So you can see that this is the screen from actual Git log. And here you can see that we just added some assertion that will check if the correct events were published or stored actually in the event store. The next step is to pass those tests, right? In order to do that, well, that's simple. We have to start writing to both sources. And once again, once we do that, this code is ready to go to the production, but you have to be aware that you should start the life cycle of the aggregates, right? Or basically this write model. In order to do that, you need to, once again, backfill the data. We use a pattern called migration event. It's really also good to consider having like separate event that is not normally used in the aggregate, because then you can actually see when this migration had occurred. Okay, but then we didn't stop here, like with the bank account, because we decided that this part of the system is too important to have the same issues once again. So we really wanted to separate those two concepts, the read model and the write model. So we also decided to implement the read part, almost like in this first picture that I showed you with the CQRS. And it was quite simple. I thought it's going to be harder. This is just a simple event handler, like we did in the workshop, that listens to events, and then based on that, updates the read model. The read model is just the old table that we used to have. It's still there. And only actually 2 columns are now considered the read model. And you can see that it's a very simple class. You could split it to 4 classes, I guess. All it does, it just updates the model, nothing else. Yeah, okay. So once we did that, we deployed it to production, of course, and shortly after, we got the Slack notification that I was really happy about. It says that there was an error saying that we cannot override rule classified transaction category with account classification. And as you remember from one of the previous slides, the rule classification is more important than the automatic one, right? So it cannot override it. The automatic cannot override the rule can override the automatic. So it's basically this, right? Manual is more important than rule. It can override it. Rule cannot override the manual, and so on. So it seemed like it wasn't enough. And this is how we imagine the system works. So when the bank account sent us the bank account sync event, and later on there were 3 handlers that were listening for that event, and they were doing some processing of the data. Later on, we rebuilt the Cashflow models. Those 3 Cashflow models are the same ones. So this is how we imagine it, but that's like how it looks like in the reality. Once again, I think this picture says more about this. So we talked to a business, and we kind of wanted to know how this thing should work. In what order should we play those event handlers to get those errors gone. So we came up with this solution that when the bank account sends us the event, of course the sync one, then we first classify it by rule, because rule from the automatic classifiers is highest in the hierarchy. Then we use the account classifier, which is lower than rule, but it's higher than global classifier. And once it's done, we rebuild the cash flow model once, not 3 times at the same time. So did we just discover a process? It's a very similar process to the ones that we did at the workshop, right? And after we looked at the code and we saw how the aggregates are used, what kind of errors we get from production, that was kind of a breakthrough. It may not sound so exciting to you because you don't work with me in this domain, but for us it was like, oh, finally. And once we understand that, we noticed that there are 3 processes that we had to implement. So we thought that let's do it like we did today in the workshop. Let's even source those as well. So we can see that where the process is hanging, if it is, on which stage it is. You can see how long each stage takes. It's also really good for debugging and troubleshooting. Also, what's really cool about processes, I hope that you saw that in the workshop, but if not, then you have to trust me that adding a new step is a pleasure. I actually showed you the production code that we are using, the first process implementation and later on, right? Adding 3 steps, it wasn't really hard. And this is how the bank accounts aggregate looks like. Sorry, the transaction classification aggregate looks like. You can see that first I classified it by account classification, then by rule and manually. And those results are solid. It's not possible to overwrite, for example, the rule classifier with the account one. And for the proof, you had the error on the previous slide. And this is how this stream of the process looks like. So we can see exactly when it happened and how much time it took. Well, you cannot actually see that, but on the right-hand side, we have more columns normally. I just cut it so it's better visibility. And to those of you who were in the workshop, you already seen this, but this is how the code for the process looks like. So this is just a bunch of if statements. And first, of course, it builds the state. Based on that state, it knows which step should be now executed. Of course, there is the load method that you can use, which loads the events from the stream. Then there is the apply method that, well, in this case, it just simple flags. It applies the information on which step we are. And later on, there is a method to store the process after it's completed. And of course, the method to answer, hey, are we done or not? Should I go with the next step or not? It also prevents you from a situation when an event comes and the process should be stopped, so it's not repeated twice. And this is how you test processes in the async world. So we did a little bit differently in the workshop. Here, you may not be familiar with the drain and sidekick job clear all, but the processes in this project are asynchronous, and that's why we kind of need to use this fake sidekick to be able to test it. But in this case, it's not a problem because it's always ordered, right? Events may come out of order, but they will not be processed out of order. Benefits. There are a couple of benefits, both for the dev team, but also for the business. So when it comes to the business, so there is a possibility to learn about our algorithm accuracy, right? Because consider the following situation. If the customer has auto-classified transaction, and then they change it manually, by manual classification, we can learn from that fact that, hey, our algorithm didn't work well, and we have more learning data, right? We can just extract this information from the events. Business rules are encapsulated, so no mistake will go to the database. Yes, the user may see the error. Yes, we may see honey badger notifications, but it will not go to the database. And all of you who worked in production environment, you know how costly it is to fix the data that is already in the production in the database, right? Sometimes it just takes a lot of time to figure out what to do with it. Should we delete the record, update it? Like hard decisions. So basically, it saves us the time and money because we don't have to debug for so long. Also, in this case, you saw that we implemented like almost the full pattern. There's only the second database missing, but we don't need that. And we did it because the business told us that this part is important and it has to work without any issues. That's why we decided to do that. We started from a CRUD, right? We added some events on top of it. Then we extracted and separated the models. We call it for now event-driven CRUD hybrid, all rights reserved. I think that's not a final name, but we'll see. All right, and this leads us to another story. And if you have a feeling that the previous one, it was complex to implement, then I won't fool you. It indeed consumes some glucose, but sometimes it's just way easier than that. And a couple of months ago, I grabbed a ticket, and the business asked to get a feedback from the user when they cancel subscription. My first idea, let's just add a column into subscription table and save the data from the UI here. And I could do that, but then I started asking myself, okay, but what's next? What's the goal? Why do you need this feedback? And I actually started discussing with the business, and I asked them exactly the same questions. And when we were talking, it just came clear that, you know, we just want this data for now, so we're able to follow up on the customers when they cancel subscription. Maybe you can offer them something, maybe you can prolong it. A lot of things can be done if you have information. So they ask, what's the simplest? Can you do Slack notification? Yeah. So it's just a notification with a feedback. And after that, I realized, okay, so I can utilize the RailsEventStore publish method, which will both persist the event in the event store, and then it will publish the event to the queue. I can simply make a handler that will fetch this event and then publish a notification to Slack. Really easy. And after that, if they decide that, yeah, but we would like to have a grouped feedback by some category or reason or whatever, yeah, sure, we can do that, right? We have this information in events. We can always access that, read a stream, and fetch that information. But also what is really cool is that we can link this event to the tenant stream. This is my test tenant, so maybe there's not so many exciting things, but what you can see is that, what you can imagine also, is that if I cancel subscription, maybe I did it because of something that I did previously. Maybe it didn't work. Maybe I got bad report results. Maybe something just blew up and I don't like the application anymore, right? But what is also interesting is that you can track when people come back, because you can also see when the subscription is resumed. And this is really funny, because I just have this thought right now, that right now we're launching a new campaign in which we prolong every user's without active subscription. We give them additional 7 days to try out the application, because we introduce a new feature. And we want to see how many of them will stay. So this will help us calculate which ones canceled and then which one come back. And we can also, on the timeline, we can kind of align it with it was the feature effect or something else. I need to tell my friends from business. And this is how the subscription payload looks like, right? So this is the feedback I told you about. We have this information, right? We can always come back to that, fetch it from the event store, and use this information. And this is the Slack notification that I used. Really beautiful, but it's enough in this case. There are more important things to work on than sending notifications, beautiful notifications. Okay, and so this is the end of my stories, and now I have to admit something. So, no, they're not fake. But a couple of years ago, when I learned that there are more important concepts in programming than latest JavaScript framework, such as CQRS, domain-driven design, event-driven architecture, they got me. I really like them. I bought the sales pitch. I saw a lot of value in them. I'm still exploring and seeing more and more value. But I had this feeling that I need to master all of them to start event sourcing. I don't know why. Maybe I read the wrong books. Maybe I read the wrong resources. But event sourcing is just a persistence pattern, right? We store an information into an event store. So I thought it's very hard, and especially I thought that I need to learn this. I need additional database. I need to learn how to manage an event store. Maybe I need to vendor log in, and it really scared me. Besides that, DDD, I need to have perfect class because then the streams get too long and I need to deal with snapshot and whatnot. I need to do right testing. I need to know CQRS. No, you don't have to know that. Well, besides tests, you better master tests or I will hound you. But it doesn't have to be hard and complex. In Trez, you rely on well-known components such as monolithical architecture. Yes. And it's 50-50 big ball of mud and more or less organized code. We have jobs. You're all familiar with jobs, right? We use Sidekick. And there's a single Postgres database driven by RailsEventStore. So nothing fancy, right? No microservices, no Kubernetes, no whatever the buzzword is. So my message to you is that don't be afraid of event sourcing. For me, it turned out not to be that complex. Actually, it's the easiest one from the patterns that I just mentioned. I really love combination of event sourcing and event-driven architecture, but event-driven architecture done wrong can be really hell and can break your application. So just use it wherever it makes sense and be aware of that and watch out for no order guarantee. And if you run into no order guarantee, I have a solution for you. This blog post by Rafa, which is available somewhere here. It's really good. It answers the question how you can deal with those. So also, when it comes to introducing event sourcing, as you hopefully saw, you can do it gradually, step by step, and you don't have to do that in greenfield. You can do it in startup. You can do it in, well, sometimes which is a greenfield, but after you join, after some time, it's not so green anymore. You can also do that in legacy projects that everyone hates. And if you ask me, that's the most satisfying to work with. And as you saw, once again, sorry for repeating myself so many times, but we started from CRUD, introduced events where it made sense, right? And once we understood the business concept better, we went through with the patterns. Sometimes we stopped, we didn't implement all of them, but sometimes it's just worth it. It doesn't have to be perfect from the start. We need to adapt to the stage of business we are in, and then we need to improve and improve. Event-driven hybrid, CRUD, it's a thing. Or rights reserved. And remember, event sourcing, DDD, like none of those patterns I addressed, they are not silver bullets. Like every pattern has its meaning and its purpose. They won't solve every problem, and you have to watch out because there are traps. Thank you, that will be all.